Hi IEVers, I'm Chanelle and I'm going to be representing your Discussion 2 leaders. I'm a little nervous on camera still, so please don't make fun of me if I sputter out words or don't make any sense. Jeff, Courtney, and I have had a great time getting to read all of your thoughtful comments and thought-provoking questions. As a student body, you all represent diverse backgrounds with incredibly unique perspectives on evolutionary change. It's been so much fun watching as we dive into the topics of natural selection and adaptation. Our first week's questions revolved around the evolutionary reasoning behind parental care, co-adaptations, and anthropogenic environmental stressors. While each question was very distinct, together they identified evolutionary concepts such as energy trade-offs, social evolution, symbiotic relationships, phenotypic plasticity, and extinction. That's a lot to cover. Most students agree that in question 1, females provide the bulk of parental care because they are biologically designed to invest energy in their offspring. The most common example supporting this was that since females possess mammary glands and invest the energy to produce milk, that they are most critical parental resource. The point was also raised that eggs require more energy to produce and carry than sperm production alone. This discussion took an interesting turn when Jared pointed out that if males were to spend more time parenting, they'd also be taking away from the time they spend spreading their genes. This would inevitably be limiting their reproductive potential, and therefore it was concluded that males sacrificing their parental roles actually better ensues the success of a population. There are also social trade-offs of parenting. For example, Kelly pointed out that parenting involvement depends on situation and environment. For example, okapis cannot afford to travel in large groups in a dense forest, and yet their close relatives, the giraffes, maintain herds where the males are more involved in a protective and therefore parental role. There are so many fantastic examples of species where parental roles were strongly reversed and where parental roles were largely shared. We're very pleased to see such a diverse group of organisms identified during this discussion and the discussion of symbiotic relationships. In this second question, many microorganisms were identified, which I thought brought great attention to the evolutionary detail of our natural world. There was some back and forth about the definition of symbiosis and what kind of relationship falls into this category. As discussion leaders, we thought it was very important to wrap up the discussion with a clear definition of what symbiotic relationships actually entail. Symbiotic relationships apply to any type of consistent relationship or interaction among organisms, which can include mutualism, where both species are benefited, commensalism, where one organism is benefited and the other is unaffected, and parasitism, where one organism benefits and the other is harmed in some way. It is very important to note that symbiotic relationships refer to any relationship or interaction between species. This discussion asks for more than just an identification of symbiotic relationships. We are also considering why these relationships have evolved. One example of this discussion component was the introduction of the concept kleptoparasitism. I like that word more than saying it. This was a new term for me personally, if you couldn't tell by my poor pronunciation, and describes when one organism obtains their food from another species by stealing it. There was a great discussion about how this behavior had the ability to become a niche for learned behavior, and it demonstrates how interspecies relationships can develop over time. Our perspective on evolution took a shift when we started discussing how humans manipulate genetics, natural resources, and biodiversity. We also got to talking about the evolutionary time frame, which reminded me of Megan's Discussion 1 summary video, where she gave us a resource about compressing Earth's history into a single human calendar year. The way we view human impacts is vastly different if we are seeing the world through an evolutionary time frame. Many students concluded that nature can handle itself, or that life will find a way, which led me to wasting a few hours watching Jurassic Park and contemplating Dr. Malcolm's chaos theory. I hope somebody finds that funny other than me. Not every species may be able to adapt to human change. However, biodiversity as a whole was believed to be survivable because of plasticity and adaptability. The jury is still out on whether or not the human race is adaptable enough to survive our own 6th extinction event. The second week of our discussion lost a little speed, but we still investigated many interesting concepts, such as island biogeography, environmental influences of evolution, and evolutionary trade-offs. We also discussed the video that was provided at the beginning of this discussion and information that we wish had been included. Looking at the discussion of the island rule, it seems that students agree that the resource availability was one of the main driving forces behind the shift in body size among different organisms. Limited availability might drive a species towards dwarfism, as it appeared to be the case where students pointed out humans on the islands of Flores in Indonesia. However, other students also pointed out that giganticism has the benefit to a species when it comes to competition. Larger species are better able to defend their territories, acquire mates, and survive longer periods of food shortages. It seems as though those that made it onto the island first and claim a particular niche and the available resources are more inclined to head in the direction of giganticism. This conversation was an easy segue into the discussion about island adaptation on Madagascar. Many species endemic to Madagascar were identified in this discussion, along with their unique physical adaptations. The methods of species introduction was important when discussing island biodiversity and geographical isolated evolution. Two methods specifically were introduced: vicariance, where species existed on an island before it physically became an island, and dispersal, where species arrived to the island after the geological isolation. There is great discussion of adaptive radiation since islands present new unoccupied niches. Niche partitioning became a major theme, with species examples demonstrating that adapting to distinct habitats and food resources may not be ecologically used yet. Nocturnal and arboreal behaviors were also identified as important ecological adaptations. Trade-offs identified energy investment and the risk of a particular adaptation. For example, cooperation was identified as a method to overcome trade-offs, since cooperation when hunting can reduce the energy spent and increase the energy gained through this behavior. Lastly, we asked students to provide feedback on the video that we provided at the beginning of the discussion. Students did seem to appreciate the clarity and simplicity of the video and pointed out that the discussion of selective breeding, or artificial selection, as a comparison to natural selection, was beneficial in understanding how and why these changes occur. However, the discussion of genetics seemed to be lacking in the video. Additional resources were provided by students, thank you Megan, and the conversation about age-appropriate material was also addressed when introducing evolutionary concepts. So this wraps up most of the material that we discovered in the past 2 weeks in the second discussion. We'd really like to thank all of you for your hard work and making our job as discussion leaders much easier. Thank you for all your novel ideas, in-depth research, and participation along the way. We hope you guys enjoyed the discussion, and we're looking forward to discussion 3. Thanks, everyone.